Hi guys, welcome to Java Syntax. This is week 3 in our HHS Robotics programming series that we've been compiling for you guys. Like always, we'll be recording these lessons and posting them on YouTube for future reference if you guys ever need to come back and rewatch this lecture of sorts. This is the wrong laptop. All right, there we go.
Oh, okay. Ooh,
So
okay.
just a reminder, hi, I'm Risa.
Okay. I thought you were going to go over with the rest of the information, but anyways, hi, my name is Jacob.
And then just a side note, thank you to Jetnel Montez. He's an alumnus from robotics who helped us with the content for these slides. So for today's agenda, we're going to be going more in depth into programming for Java. So we're going to be going over concepts like primitives, variables, operators, math, Boolean and conditional operators, control flow, the procedures or functions and classes. And then we'll go more into FTC programming, and you guys will be able to see a little bit of how we would be programming on Android Studio if we were back in the classroom.
Okay, so I just want to interject real quick.
Oh yeah.
Okay, so we are going to be covering a whole lot of concepts in literally like 1-2 hour lecture, when in fact, all these concepts that we're about to teach you guys, this would traditionally be taught in like a whole semester. So don't worry if it's a lot of information, because it's definitely a lot. But at the end of the day, you don't need to memorize all the syntax. What you really need to understand is, as a programmer, you obviously do write programs, but really you're a problem solver. And like, how should I say this? You don't need to remember all the syntax, but you do need to know how to approach a problem. So you just need to know that you have to use like these certain kind of variables, or use these kinds of control flow, like if-else statements and all that. You don't need to remember everything right now, but this is just kind of like introduce you guys to like all these different concepts that you could use in your programs. And you can always look stuff up if you forget them, pretty much, because pretty much all programmers look up stuff online if they don't know anything, like on Stack Overflow. So yeah, it's definitely a lot of material.
So double checking, did everybody happen to get the chance to make a REPL account?
Yep.
Ooh, thank you, Emma. I appreciate it. Lexi, Ruben.
Yeah, I made one.
Ruben. Okay. Okay.
Okay, so if you haven't made a REPL account already, we will be using REPL to kind of demonstrate the code working and all that. We're going to invite you guys to a little REPL that we can all collaborate on, like we did like 3 weeks prior. So that's kind of why we want you guys to have a REPL account. But I think we can go on.
All right.
Yeah. Okay, so basically in programming, you always have to like use information. You have to store information and you have to manipulate it. And so the way we store these like types of information, these data types. Okay, I didn't. Oh my God, this is the thing with winging it. Okay, so we store information and we want to manipulate it. And so in Java, there's different ways to represent this information. So there's different types. We have the Boolean data type, which pretty much just stores either a true or false, so either a 1 or 0. And so an example could be for a variable, if you can make a variable called is hungry. Are you hungry? You know, there's only 2 answers to that. It's either yes or no. It could be true or false. So you can make a variable Boolean is hungry, and then, you know, are you hungry? So the next 2 data types that we put in here concern with numbers. So we have the integer. And just like in math, an integer is just a whole number. You can store positive whole numbers and negative whole numbers. So you can store 0, 1, negative 10,000, and that really long number that I'm not going to read. And then the last data type that we'll talk about is the the double data type, which basically stores decimal values. So you can see that we can store 0.234, 0.5, and negative 1.345. So more exist, but these are the most common, most like relevant types in FTC.
And then just a side note, doubles, although it is decimals, just keep in mind that fractions do count too. Because I mean, a fraction is just a decimal, 2 over 5.4, you know?
So we just talked about different kinds of information that you can store in Java, but how do we actually write this in code? So these are what is called variables. And so you have the name of your variable, kind of the data type of that information or that variable that we talked about in the previous slide. And we also have data that we assign to that variable. And so when we talk about variables, we're asking ourselves the questions of, what is the name of our variable? What is the variable type? If we're going to store a Boolean or some number like an integer or a double. And to break down this kind of statement on the right, you can see that we have our data type, which is int. And then we have the name of our variable, which is num. And then we have the equal sign. And so you can, in this case, you want to think of it as kind of an assignment. At the very right, we have our data value, which is 1. And it basically tells Java to set num equal to this. So whatever's on the right. So our data is 1, so we assign it to num. And you can see that little box, that's the num box. And inside the num box, there's the 1. And yeah, all Java statements end in a semicolon. Remember the analogy that we made earlier about how writing programming statements is kind of the same vein as just writing a sentence in English. And so you know how you end every sentence with a period. In programming, at least in Java, you end your statements with a semicolon. It's just like your period. Good programming practice is assigning variables before they are used or needed. Basically, how should I relate this? Okay, so let's say you're making a program for your robot. You want to make variables for the hardware that you'll be using. So you're going to make variables for your left motor and your right motor, your back left, back right, And so you can initialize those variables ahead of time so that later on in the code you can then manipulate and use those variables. Well, not really variables, those are really objects, but we'll get to that later with classes. Variables can be primitives or data types. So primitives are basically the data types that are inherent in Java. Like Java already knows those kinds of data types. But with non-primitive variables, how should I explain this? They're variables that are user-defined. So say, for example, you wanted to create a variable, but you wanted to store information about a person. And we know that storing information about a person is very complicated because there's a lot of stuff you can talk about when it comes to a person. You can talk about the name, the age, the height, interests, things they can do. I mean, every person sleeps and eats. And that could be made into its own variable called like human or people or person. And that would be a non-primitive variable. You don't really need to know that kind of stuff. It's very kind of technical, but that's basically explained that little bullet point.
So math operators,
You can go ahead.
Okay. Math operators are essentially, for the most part, just the normal operators that you see in math, your plus, minus, divide, and multiply. So for this single equal sign, this is the assignment operator. And so in this example here, you're saying that x is 2. For the plus equal operator, all it's saying is x is equal to x plus 4. So this plus sign happens before the equal sign. So like x plus 4 is equal to, and then assign your output or whatever you get out to the variable x. And then likewise, same procedure for subtraction, multiplication, and division when it's minus equals, times equals, or divide equals, where we have y minus 6 and then store that result into y. So this percent symbol here is a modulus. All it means is I want to take the remainder of something. So for example, if let's say n is equal to 20, or actually not 20, let's go with 15. If n were to be equal to 15, it would be 15 mod 10. So 15 over 10, the remainder would be 5, so n would end up being equal to 5, if that makes sense. And then for math.abs, it's just the absolute value. You'll be seeing this a lot, particularly for tele. So it's just your normal absolute value. So let's say if we have math.abs -5, the absolute value of -5 would be equal to +5.
Okay, so I just want to interject real quick. So when you're looking at that meaning and you read x equals x plus 4, that might not make sense because, you know, we've been learning in like algebra that you like, well, okay, no, it just doesn't make sense in algebra, right? X can't equal x plus 4 because if you cancel out the x, it's just 0 equals 4 and it doesn't make sense. But in this case, remember that when it comes to programming, equals means assigns. So it's like whatever expression you have the right side, once you evaluate that, that's the value that you're going to assign into x. It's not algebra. It's assigning, basically. It looks weird, but you'll get used to it. Yeah.
So just like adding on, let's say we have the x is equal to 2 here. I would start with evaluating 2 plus 4 and then assign, in this case, it would be 6, assign 6 as the new x value.
Yeah, we're good.
So here we just have like an example. We've declared two num variables, num1 and num2. Num1 and num2 are both integers as specified by the int in front of them. Num1 is equal to 2 and num2 is equal to 3. So num1 plus num2, if anybody wants to either unmute or type it in the chat, would be equal to what? Nice. Thank you, Adam. Thank you, Emma. So then likewise, num2 minus num1.
One.
Thank you. And num1 times num2.
It's 6.
Thank you. And then num1 divided by num2, although you would normally get 2/3, it's a little bit more than that. So you end up with 0, and this is because num1 and num2 were originally integers, and so your result also has to be an integer. So if you take a look, see num1 over num2, 2/3, which is 0.666, blah, 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 right? So this entire portion after the decimal just gets yeeted out, and you're left with 0. So it doesn't actually like round up like we normally would. It just cuts off. So then we have doubles. So in this case, we have num1, which is 2.5, a double, and num2, an int, is equal to 5. So num1, and then just a side note, if it's an integer plus a decimal, then you'll end up with a decimal as a result. So with that in mind, num1 plus num2 would be
7 mark?
Have confidence. No need for that question mark. It is 7.5.
It's too late. I already said it. Aha!
Anyway.
And then likewise, num1 minus num2. Thank you, Adam. Negative 2.5. Num1 times num2. Thank you, Adam. 12.5. And then num1 over num2.
Let's have a 5.
Am I allowed to use a calculator?
I mean,
Yes, you are.
I think. Okay.
Yes, thank you, Adam. 0.5. Oh wait, did I missed? Okay, that's a typo. It's 0.5.
It's
Look
0.5.
Anywho.
Yeah.
Can
I go over
you
this?
want to take care of?
Yeah.
Yep.
So basically, we talked about doing operations on values on numbers, but we also talked about the other data type, which is Boolean, which is true or false. And there's this whole sector of Java called Boolean Algebra. And so basically, instead of operating on numbers, you're operating on Boolean values of true or false. In this case, we have, let's see, we're using comparison operators for Boolean stuff. So our first operator is the equal sign, so double equal, and it means equal to. So, oh wait, no, that's a little, okay. Okay, in this case, we're comparing values here. My bad. That's the next slide. Okay, in this case, we're comparing values. So we have this example over here, 3 equals 3. And that basically is saying, does 3 equal to 3? And I mean, does anyone want to answer that question? Does 3 equals 3? And so when we're trying to evaluate this, it's either true or false. Does 3 equal 3? Is that a true statement or a false statement, pretty much?
True.
Yes, it's true. So where's the t? There it is. Okay, and so we're comparing two values and if they're equal to each other. The next operator is the not equal to. So it's an exclamation point followed by equal sign. So again, we're comparing two values. We have a 1 and a 4. Is 1 not equal to 4? Does that statement make sense? Is 1 not equal to 4? It's true, yes. Adam, okay. So the next operator is the greater than sign. So pretty much, is 5 greater than 5? Is that a true statement or not?
False.
Yeah, it's false because people like to mistake, oh, they're the same number, but in this case, it's only asking if the left value is strictly greater than the right value. However, the next operator you'll see is the greater than or equal to sign. So it's asking the question of, is the left value greater than or equal to the right value? So is 3 greater than or equal to 3? Is 3 greater than or equal to 3? It's true, yes. 3 is equal to 3. It's not greater than, but it is equal to. Then we have the less than operator, again comparing two values. Is 4 less than 3? Does that make sense?
No.
Yeah, not really. Those numbers need to be flipped around. So in that case, that is a false statement. And the last one is the less than or equal to. So we have our example over here. Is 3 less than or equal to 3? Is that, does that make sense?
Yeah, no, you're chilling.
Okay, yeah, I think these are pretty obvious at this point. They're pretty self-explanatory, but you guys get the gist. So let's get on with the next slide, which I was explaining things ahead of time. So now we're talking about specifically Boolean operations. So I'm just going to read the definition. So we have conditional operators, which basically chain two or more Boolean operations together. So say, for example, I'm trying to think of an example for this. You can use the AND operator if you wanted to use multiple controller inputs to do one thing. If you had to press both the A and B button at the same time on your controller to do something, you would use the AND operator. So what I made over here are some truth tables. So you can see that there's just like zeros and ones. So basically 0 is false and 1 is true. And again, because this is Boolean algebra, we're not comparing two values, but instead we're comparing two Booleans. So we have a Boolean A and a Boolean B. Let's go to the first truth table. So we can see that for the AND operator, if either A or B has a value of false, false, then the returned value is going to be false as well. However, if both Boolean A and Boolean B are true, then that means that the end result will also be true. Basically, and is like if both are true, then this must be true, else false. The next Boolean operator is like the two vertical lines. I'm not sure what they call that, but that's basically your OR operator. And in this case, again, you have two Booleans. You have Boolean A and Boolean B. And as long as either one of the Booleans are true, then the end result is going to be true as well. The only time that the OR operator will not return true is if both the Boolean A Boolean and the B Boolean are false. And then for the last truth table, we have what's called a not operator, and it's indicated with the exclamation point. And so basically it takes a Boolean value and it just inverts it. So if you have a false statement, if you put an exclamation point before the Boolean value, it becomes true, and vice versa. This can be used whenever you want to how should I explain this? Let's say you have 7 days of the week. If you wanted to represent the weekdays, instead of having to put comparing Monday, Tuesday, Wednesday, Thursday, and Friday, you can instead put is the day Saturday or Sunday, and then put your exclamation point or not. So if it's not Saturday or Sunday, it must be the weekday. I guess that's like an example for the not operator. It's a way to just make things easier on yourself, and it could also make the code more readable. Yeah. Okay, so note, we just talked about the double equal sign and the single equal sign. Yes, they use the same signs, but they're very different things. The double equal sign compares values. It checks for equality. And so it's going to return a true or false Boolean. A single equal sign only assigns a value. So on your left would be the name of your variable, and on the right would be the data which you'll assign to that variable. They're two very different things. People tend to mistake it a lot, especially when we get into control flow and you're just going to use a single equal sign to compare two values, but no, you have to use two equal signs. Yeah. Okay, I'll go over this as well. Programs aren't just strictly running on their own. They have to make decisions as well. They need to repeat actions based on inputs. And this concept is called control flow. So here's kind of the little flow charts that we made from a few weeks back. You can see that there's the diamond shape things, and they basically indicate decisions. So I'll tell you right now that those diamond shapes are basically if statements. If the left stick or if the right bumper, if any of those inputs are true, then that means we're going to do kind of the code inside that block. So if we move the left stick, we're going to move the robot, and there's all those other functions. So that's basically kind of what control flow is. It's just making decisions on whether or not you want to do one thing or another thing based on a conditional. We have these three types of control flow constructs that we'll be talking about. We have the if-else statements, and we also have the while and for loops. There's many more, but these are the most commonly used, most relevant in FTC. Do you want to do this?
Alrighty. So for the if-else statement, it's identified with while, if, and else. But essentially, all it's saying is if this condition is true, I want to do this thing. But if it's false, I want to do something else. So if you notice, the if statement has a condition 12 equal 1, whereas the else statement doesn't have any conditions inside any parentheses or anything like that. So your else statement is going to be what I like to call unconditional. It will love you unconditionally. If all else fails, this is your go-to hype guy. Yes. But yeah.
I never thought of it that way, but that makes sense.
Yeah. So you also have your if, else, if statement. So if you notice, we just added on a little else if in between our if and else statements. So do note that you can have multiple else ifs. So if I wanted to check for 3 conditions instead of just the 2 that we have here, I could just be like else if and then the else after. But essentially, if we take a look-see over here, is 13 is less than 5, it's false. So we move on to the else if. Is 13 equal to 5? Also false, we end up moving to the else statement. So our if, else if statements are going to run from top to bottom, and it's always checking for, is this condition true? If it's not true, I'll move on to the next potential condition until we do find a true condition or we end up with the else statement. Do note that if hypothetically this were to be true, we wouldn't end up checking any of our other statements below it. Yes, okay.
As Jet would say, he would cry. Yeah. Again, we just kind of transferred the slides, so anyways.
So then we have while statements or while loops. So essentially, they run forever until the condition inside the parentheses is false. So in this case, what we have is we're starting with a variable called count equal to 1. We substitute the 1 into count. So is while, if 1 is less than or equal to 10, which it is, this is true, we end up running everything inside of these squiggly braces. So we print out count is 1. And then this is called an increment. All it's saying is to add 1 to our count variable and then assign that new value to the count variable. So instead of count being equal to 1, with this count increment, now count is equal to 2. We loop back around to the top. Is 2 less than or equal to 10? It is. We go ahead and keep looping this until we end up with, in this case, count ending up being 11 when we're incrementing it, because we'd end up with 11 less than or equal to 10, which is false. And so then we move on.
Okay, so I just want to interject that we also forgot to mention what plus plus and minus minus are. It's pretty much just adding 1 to your variable or subtracting 1. It's useful for stuff like loops where you just want to count. You have a counting variable. Just wanted to point that out. Plus plus, add 1, minus minus, subtract 1. Okay, can I do this?
Okay.
Yeah. All right, so basically now we're going to talk about methods and functions. So it's pretty much a block of code that is reusable. And Risa, I think, what's the analogy that you have for this?
Oh, for functions, hold on, let me, okay, is it, I cry, I'm gonna have to, hold on. There we go. Okay, so this was high-key linked from code.org, so thank you, code.org. But essentially, all a function is you're taking a set of procedures or steps, giving it a name, and then you can use that new name whenever you want to execute those steps. So like in more easier to understand terms, let's say that we have a song over here, we have the chorus repeats every single time we get to the chorus, right? So instead of having to rewrite the chorus every single time we want to reference it, we can instead make our code a little bit shorter and say, oh, sing chorus, it refers back to this chorus over here, sing these lines, and likewise, wow, sing chorus.
Santana, are you
I go
around?
back and reference this chorus definition
Okay,
here.
we're gonna go back to this part, and now add.
Does that make a little
Yes,
bit of
I
sense?
am. I just,
Like,
I'm on one of the.
it's beneficial
sessions.
because
Okay.
it's easier
Yeah,
to read.
I'm doing
because
PD,
instead
bouncing in and out of
having
these
to, like,
rooms, answering phone calls from
look at
parents.
four
it's
lines of
been one
code
those
whenever
days.
we want to refer to the
Okay.
chorus. It's just wow, chorus, and likewise,
Going
you can
through
visually
intros right
see
now, and they're
it
going in
takes
order, and
up
I'm like,
less.
crap.
For
They're
what?
going through intros right now, and they're going to go in order.
For what?
Just intros for whatever session I'm in.
Oh, I'm not doing
Okay,
that.
so now we're back to here.
I'm in
Yeah, that was a really
Calentars
good analogy. I
'cause-
couldn't really think of anything other than it
Oh,
just like
That's
repeats
cool.
stuff.
Can you send me the link? I'd rather go to that
Okay,
one.
so it's always in a class.
Yeah,
So
let
we'll
me-
talk about
hold on.
Java class at the very end.
I don't know if I can send you the link.
But,
Go to the Bitly.
yeah.
I'm on two
Basically, your
computers. Hold
method
on.
consists of kind of the return type. So you have int, and then you have the name of
Antonio,
your method, which is
I just want you to
add,
know,
and then
it's
in the parentheses,
probably not
you're going
with
to
his
have what are
team.
called parameters, and those parameters
we talked
themselves
about
have
it.
a
He
data
said
type.
most of his team was in
So
the
you can
programming or the
specifically, when we
CAD
want to
session.
put in whole numbers into our parameters,
So
integers, and then basically kind of like
this is
variables. We're
just
just
between you
substituting what
and
A and
me.
B are.
Risa and Caleb already
So
know.
we're just going to return the value of 3 plus
Caleb
4,
and Antonio
you'll
are
see
going to
that
come
little
to my
box,
house
our new
tonight and build
box,
the field.
It's 7.
Oh, okay, cool.
So yeah.
But Antonio has to go get clothes to do his senior pictures with. And he was going to do it after 3.
Yeah.
But I told him I would pick him up on my way home to go build the
Now we're
field,
going to
so he
talk
convinced
about-
his mom to
so
go do it
all
early
this
so
stuff
that
we've been
he could
talking
be
about,
ready
so
for
for
me
all
to pick
these
him up
concepts,
later.
they're all going to be contained
Gotcha.
inside Java classes.
So
found
you-
the link, by the
essentially
way.
Well, that's good
blueprint
because I haven't been
behaviors
looking for
become an
I mean, I'm sitting here
object.
staring at it, but I
for me,
haven't
like
figured out how
think
to
about
copy it
it
and
as
give it to you.
characteristics and behaviors.
Anyway, he didn't
So
want you to
we
be
know
mad
that
if you
with
went to
any
his
animal,
Google
some of
Meet
its
and found that he
behaviors
wasn't
might
there.
be that it's going to
Okay,
eat.
no problem.
It can
So I was
also
just letting you know.
We can't really
I'm
name
gonna
any
run to the
characteristics though,
bathroom, and then I'll
because
be
this is
right
a
back.
very broad like
All right.
generalization. This is like just an animal. We don't know exactly much else about it. But what we can do is we can extend classes. So we can basically extend our behaviors and characteristics to something else. It creates what's called an is a relationship. So we can say that dog is an animal, and dog is going to inherit, it's going to have all the properties of an animal, because a dog is an animal, it has to eat and it has to sleep. But something specific to a dog is that it's going to bark. It can bark. So that's what I put right there. And it's a one-way relationship. So it's very important to understand that is a relationship, because it wouldn't make sense if you did public class animal extends dog, because basically what you're saying is animal is a dog. That's not true. Not every animal is a dog. An animal could be like a zebra, a giraffe, a bird, anything else. But it works the other way around. A dog is an animal. So, like not every animal is gonna bark, basically. I don't think zebras bark, do they? I don't know, but yeah.
So another way you could think of it, thank you, Isla, for this analogy. But if any of you guys play like video games and you're creating a brand new character, you make your character, and you know how like sometimes you'll have different classes of characters. So like mages, let's say, we can essentially, when we make our new character, let's say we want the mage class to define our character, all of the characteristics of a mage end up being applied to our new character. So our character has become a mage by essentially extending.
Yeah, that actually makes sense. I never thought about that. That's a good analogy. Okay. Okay, so in this next slide, I basically put some random objects here, and we're gonna try and think about how we can turn these into a class. Oh, okay. So let's talk about this soda can. So we know that a class is made up of characteristics and behaviors. So first of all, what's the characteristics of this soda can right here? Like, what do we like? Just what's the characteristics? Yeah. Okay, so we know that the color is red, so we can perhaps make a variable that stores information about the color, which in this case we'll have to use a string data type, which we did not cover, but that's basically it. Yeah, we can have a variable that contains the word red in the variable color. What else? What other characteristics? Well, characteristics don't have to be like literal. It can also just be like stuff you see. Like you can see that there's like the word sprite, so that could be like another kind of variable, but this time it contains kind of like maybe like the brand, I guess. And then we can also do cranberry. So like, what's the flavor of this soda anyway? What's the flavor of this Sprite? So we can have another variable, another characteristic that just talks about the flavor. Okay, so it's cranberry. Yeah, so there's stuff like that. What else can we talk about? Okay, well, we're done with the characteristics. Now let's talk about kind of like the behaviors. Like, what can you do with this soda can? Like, yeah, what can you do with this soda can?
Spill.
Okay, so we can have a behavior that's like it spills, I guess. What else can we do with this soda can? With this Sprite cranberry. Okay, well, first of all, it's a soda can. Yes, drink from it. So that's going to be a key behavior. We want to drink from this soda, you know. It's got all that Sprite cranberry in it. We're going to drink it. So yeah, that's just kind of how you can think of like real life objects and turn them into classes. You have characteristics. Oh yeah, another characteristic could be like how many milliliters of like the actual drink there is. I forgot about that. But and then you also have like behaviors, like you can knock it over and spill it, or you can just drink it. You can also open the can, you know, because you know right now it's probably like closed. You need to open it. Those are other behaviors that you can kind of do, or like other things you can do with it, pretty much. So let's get to our next object. Let's see. So here we have a bicycle. Let's think about what characteristics does it have. What can you see? What is there? Okay, yes. So we can do like color is red. Ooh, there's pedals. Okay, so we can make a variable. This time probably maybe an integer because we're gonna store a whole number. There's 2 pedals.
2 wheels.
There's 2 wheels. Yep. So we can have another characteristic talking about how many wheels there are. You can get very specific. You can talk about maybe the diameter of the wheel. Okay, yeah. What else? Because I think there's more you can take out of this that you might not think at first. Yes, so the seat. Specifically, what about the seat? What about it? Are you talking about perhaps the color or the seat height? Because I feel like seat height would be something we can talk about with a bike as well. That could be another characteristic. Okay, so we know all those different things. And then, you know, what can we do with the bicycle? What can we do with it? What's like some behavior?
I mean, like I could ride.
Exactly, you can ride the bicycle. It's pretty self-explanatory. Yeah, that's pretty much like the one main behavior. You can go more in depth and be like, oh, you can turn and, you know, do all those different things. But yeah, basically that main behavior is to just write it. Yeah. Okay, so let's see the next object. Okay, so we have some books, or I wanted to put a notebook, but I didn't put it in here. But what are some of the characteristics you can take out of a textbook, a notebook, any of those things? What's some characteristics? What's some stats?
Math.
Like what do you mean by math? Like,
The weight.
oh, the weight. Okay, so we can talk about characteristic being the weight of the textbook or notebook, I guess. The amount of pages, yes. So we can have, some characteristic being an integer storing the number of pages in your notebook. Yeah, what's some other characteristic? Maybe perhaps about the pages themselves. Think about it. You can talk about the size of the page. You can also talk about if it's college ruled or it's just like the regular line paper that's like really big line, like separating the lines and all that. Hardback or paperback,
Wide ruled.
yes. Huh?
Wide ruled.
Wide rule, that's what it's called. Wow, I'm dumb. But you get what I mean. Yes, hardback or paperback, yeah. So yeah, we named some characteristics. Now, what can we do with like a notebook or textbook? What can we do with it? What can we do with it? What's some behaviors? So I mean, if we're talking about a notebook, okay, so with a notebook, you obviously write in it to take notes. So you can have a behavior being like, or a method like, write in the notebook. And you can write like, I guess, a page, and then you can put like in a parameter some text that you'd want to add to your notebook, something like that. What's some other behavior besides writing in a notebook? Let's say it was just a textbook. You can't write in it, but what can you do with a textbook? What can you do with it? You can read it. Yep, that's like the main thing. You can take information from it. You can make a behavior, and it's like read, and you just read. Maybe you can do a parameter that specifies which page you want to read out of the textbook. You can do something like that. So yeah, there's behaviors and characteristics with those books as well. And then we have our last little object, although we're not really going to get into it. So we have all these different classes, but what we're really working up to is we want to create the class for, wait. Is my thing lagging? Okay, well anyways, the last picture is going to be the robot, yeah. So this is what we're going to be working up towards. What are the characteristics and behaviors of our robot? So by characteristics, we can name stuff like how many motors there are, how many servos there are. And then we have behaviors. We have those 4 wheels on the bottom. What can we do with them? We could probably maybe go forward, go backwards, all those different things. And we also have like a little lifting mechanism. So perhaps we're going to make more methods about that. So yeah, I really like doing these kinds of analogies. It really made more sense to me. Like literally in my freshman year, I couldn't wrap my head around classes, but being able to understand that a class literally just has behaviors and characteristics, it just made everything a lot easier for me. So hopefully these analogies like just help you a bit more with tackling this Java class and all the other stuff. So yeah. All right, so anyways, we already talked about, figuring out what behaviors and characteristics of an object are, but now we're actually going to code a whole Java class. Let's get it. So if I can get the invite. So if you have REPL, I'm going to put the link. So kind of like a few weeks back, you were able to join our REPL and we're able to kind of code live, kind of like a Google Doc, like we can work together and whatever. So we'll wait for a little bit, see if people join. Wow, that's a rip. Okay, how are we gonna go along with this? Okay. Ooh, there's also examples to use, but that's okay. So I'm gonna wait like a minute or two, and then we can kind of explain kind of how to write our own class, pretty much.